Soil pH, what is the big deal? Soil pH can have a significant influence on the nutrients in your soil and your plant's ability to actually get to them. If your pH of your soil is not near that neutral range, you can actually have nutrients in your soil, or you could be putting out fertilizers that are not readily available to the plant and the plant cannot use them. They can actually be sitting there because of the chemistry going on in your soil with high and low pHs. You can actually have nutrients in your soil that cannot be available to the plant. It's one of the reasons why they often call lime the poor man's fertilizer. In addition, there can be some influences on your pesticide applications. So we're going to go over that, the nutrients. We're going to go over how it affects your pesticide applications, the options that you have as far as what to put out. We're going to talk about lowering and raising pH, and I'm going to give you a pretty good idea of exactly what's going on as far as what is and is not plant available at the various pHs. Okay, so we'll talk about nutrient availability. Let me show you this chart. Okay, this is a chart, and you can see on your left is a soil pH of 4, on your right is a soil pH of 10. The soil pH chart, well, the pH chart, relative for everything, goes from 1 to 14. 1 being acidic, 14 being alkaline, 7 is neutral. Okay, now you can see on this chart, look at nitrogen. If you got a pH of 5, and I have seen pHs of soils as low as in 2s, now that is not, or is unlikely in your yard that you're going to have a pH of 2. I've seen some wild stuff. But if let's say it's 5 to 5.5, look at nitrogen. And nitrogen one is the major contributors to growth, to greenness, a lot of things going on, particularly with turf and nitrogen. You can see how the plant availability starts to diminish. Thicker line on this chart being more available, the thinner the line, the less plant available that nutrient is at that particular pH. Also, phosphorus for seedling vigor. Okay, if you have just seeded your yard and it's a low pH, phosphorus helps your brand new seedlings grow more faster, if you will, seedling vigor. So we're talking about seedling vigor, and also stun it. Look at potassium's a really interesting one as far as soil pH. Look at the 5, how much it starts to go down. But look, for those of you who have pHs of 7.5 or greater, look at the potassium. Look what it does as soon as it gets to 7.5. It goes right down. And potassium is for rooting, summer and winter hardiness, depending on your grass being what it is. A lot of things very important with potassium. And if you see the micronutrients, I did an iron video I'm going to leave here at the end for those of you, particularly out west, that may have to manage some of these high pH soils. But I'm going to leave my iron application video at the end. It goes through how to apply iron and a lot of chelates that you can use on these micronutrients. Typically, you can get chelated products, okay? And it allows those micronutrients to be more stable at these higher pHs. So my iron video went over that in completion. But my point I'm trying to make here, you can see the iron, manganese, boron, copper, and zinc. You can see how on the higher pHs, how those can be plant unavailable. So it gives you an idea of how influential, if you will, and how important it is to have that pH between that, probably about, I like to keep mine about 5 to 6. Some of you out west, that's not going to be possible. It's just your soils, the way they are, the salts in the soils and various other things that I'm going to get to here in a minute, are going to be prohibitive for you to get that pH that low. So anyway, but let's talk about pesticides real quick. As far as their, I'm going to leave it's a University of Michigan publication. They are primarily talking about when you mix pesticides with an alkaline or an acidic water, okay? I'm just giving you a vibe for how much that this can actually influence things. They go through a chart there and they give you active ingredients. And I'll just throw out one right now. Trichlorfluoron, okay? It can, if you're mixing it with water at a pH of 6, it can last in that tank and still be effective for 3.7 days. If you mix it with a water with a pH of 8, it lasts 63 minutes. So it gives you, I'm just giving you an idea. Don't sweat that too much. Don't sweat this too much, but I'm giving you an idea how important it is to get that, to get your pH of your soil near that alkaline. It can influence things. The two major things it does influence it does not influence your fungicides that much. Primarily, what you guys are putting out is propiconazole. I think it's, what's the other one? Oh, microbutanol. Those are the DMI fungicides that you generally have available in home lawns. The thiophanate methyl, not on that chart in there, and I don't know if it really influences, but long and short, as far as how pH influences your fungicides, for those that are available for homeowner use, um, typically not a whole lot of influence. It's the pyrethroids, your surface feeder insecticides and organophosphates, the ones that are for grub control primarily, and subsurface feeders that feed on your roots. Those are the ones that can be influenced by pH. You have got to get a soil test in order to know what you're doing as far as increasing or decreasing your pH. I recommend, I'm going to leave my soil test video here at the end. It shows you how to take the test, how to fill out the paperwork, how to submit it, how to interpret the results, soup to nuts, everything you know about taking a soil test. You will take those recommendations that they will get back. I recommend where to get these done. Soil tests. Go into Google. We're on YouTube. Go into Google. Type in soil tests in your state. They will give you the local university that is in your state that does soil test. Every state in the union, including Alaska, has, I think, the University of Alaska in Alaska, Clemson in South Carolina, my alma mater, NC State does it in North Carolina, West Virginia University does it here in West Virginia, Penn State does it in Pennsylvania, blah, 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 blah. Florida, Texas A&M, Texas. That's the best source to get a soil test done. One, typically for free. If it isn't, I think Clemson charges you $8. It's $8, not a big deal. You can get them in. So see my soil test video, send them off to them. If you have questions, I have found that these folks, they're kind of science geeks and soil geeks anyway. They're happy to talk to you, particularly you guys who are trying to lower pH. We'll get to that here in a minute. May need some guidance on what all is going on. Typically, when you get your soil test results back, I say this in my soil test video, they sometimes, if you have a pH below 5.5, okay, they typically will kind of burp out to you 2,000 pounds per acre, or they'll do that on 1,000, sometimes they'll do it on 1,000 square feet, usually get at 2,000 pounds an acre. I'll get to the math on that here in a minute. If it's less than 5.5, call them back, call them back and say, hey, I think this recommendation is light, which it is. I don't know why they do this. But once when they get up to 2,000, that's all they tell you to do, even if you have a pH of soil of 2.5. Remember that 2.5 soil I actually talked about? I actually got it, and I called them back. I said, this is not even close to what I need. It turned out I need about 6,000 pounds of the acre because I had a pH of 2.6 or something like that. Anyway, but if you have I'm just throwing something out. If you have a pH less than 5.5, give them a call back. And they will calculate, they will look more at the calculations. They'll give you a better recommendation on how much actually you need to put out on your soil. And yes, you can put it all out at one time. This stuff is pretty safe to put out. I'll probably go ahead and leave a link. I will. Down below, I'll give you a spreader calibration chart that I've used in my other videos. It is a great one. The SGN on most of these, in fact, almost all of these pelletized lime products, the SGN is a 150. So you look at that chart, the SGN, and how many pounds you need, and it gives you the spreader settings. So on lime, you typically have two types of particle sizes. This is pelletized. Put it out. Use this. There is a pulverized lime, which is somewhat, what it is, it's a little, it's larger than talcum powder, smaller than sand. There's really no good way to put it out on the lawn. I only say that because, one, just giving you some exposure to it. Somebody may talk you into it. It does react faster, but there's really no good way to put it out. It will throw dust. It will dust all over the place. You'll end up on your neighbor's yard. It just blows all over the place. Gets in your nose when you're trying to breathe. It's a mess. Stick with the pelletized lime. Now, dolomitic versus calcitic. We're talking about raising pH. You have dolomitic limestone, which is, if you have a magnesium deficiency, you can use dolomitic limestone. It has some magnesium in it. Calcitic limestone is just calcium. The nice thing about calcium, I've seen some studies, the calcitic limestone reacts a little faster. Typically, these products, when we're talking about raising pH, particularly with lime, will take anywhere, kind of start really reacting within 2 to 3 weeks. You'll start, if you had a pH probe and actually putting it in the ground, you'll start seeing some increase in about 2 weeks. Typically, it takes anywhere from 3 to 6 months to change pH on lime. That is typically the case in raising pH, and I'll put some caveats on that when we start talking about raising pH. We're talking about lowering it right now. Okay, now, on these bags, you will see, let me scoot way over here. This bag blew up. You will see calcium carbonate equivalent. Calcium carbonate equivalent is, okay, when you get your soil test back, you will get so many pounds per the acre, and then it will say 100% calcium carbonate equivalent. It varies from bag to bag, to product to product. It will be on the back of the bag. It will give it to you on a percentage basis. This is what this one looks like, okay? This one's 83% calcium carbonate equivalent. Okay, now let's do some math. Not complicated math, just gotta do some math. When you get your soil test back, it will say 2,000 pounds to the acre. You will need to take the 2,000, do the math here real quick. 2,000 divided by 43.5. That gives you how much you need per 1,000 square feet, because there's 43.5 thousand square feet in an acre. Okay, so you're taking your ton, the amount you need, divided by that, gives you how much you need per 1,000 square feet. Then, take that number, put it aside real quick. Take, in this case, it's 83%. You will take 100 minus 83. That gives you 17. Then, okay, you take how much you needed per 1,000 square feet. I think it's 50, but anyway, I'll show you the math here. Multiplied by 1.17. Where I got that 1.17, remember? 100 minus 83. Multiplied by 1.17. That is how much you will need of this product per 1,000, how many pounds you need per 1,000 square feet. Then you take how many 1,000 square feet that you have in your yard, multiply it by that poundage, and that gives you how much lime you need to put out on your yard. So, not hard. The reason why they do the calcium carbonate equivalent is it varies from bag to bag, the percentage of calcium that's in it. So I've seen as low as 70% or 75%. This one's 83. There are other lime products that go clear up to 95%. There's a quick lime, it's pure calcium oxide. Don't use that on your, that is out there. Typically, calcium oxide is used by farmers. They typically till it in the soil. It acts very quickly. It's called quick lime. Don't use that on your turf because it's just way too alkaline. It's too hot. I've had, believe it or not, a cattle farmer one time tried to use it on his field and didn't work out too well. It really just burned up his meadow. So anyway, don't do that. So anyway, that's how you figure out how much you're putting out in your yard. Use that fertilizer chart if it's less than, if you're not putting out that much. There again, most of these products are pretty doggone safe to be putting out. So anyway, one thing I do want to expose you to, probably not quick, liquid lime. This is, I don't know, kind of new on the scene, probably 15, 20 years. That's kind of new, considering they've been using this for a couple hundred, or longer actually, probably. But anyway, these liquid lime products, this is a CalFlow used this on a large project, a large hydromulch project. There are some professionals that actually watch the channel. Hey guys. I just want to expose you guys to some of these. They do react very quicker than the pelletized. There again, I said it takes about 2 weeks, and then you really don't start getting results where you need to be within 3 to 6 months. The liquid lime does work. It does work quickly. Where it is handy, if you are hydromulching, for example, and you have a low pH soil, and you're wanting to get good seedling vigor and make sure your phosphorus is available and the pH is good, you can actually mix the liquid lime within that, or you can spray it out of the backpack spray if you want to. The problem is with this recommendation on this tells you anywhere from 2 to 5 gallons per acre. That comes to about, at the 5 gallons per acre comes to about half a gallon on a typical yard. So in other words, you're going to have 2.5 gallons of this stuff sitting in your garage for gosh knows how long. So the practical use of this, particularly this product in a 2.5 gallon jug, is not really practical. I have seen on Amazon, I was trying to look for one. It was in a smaller container, like a half gallon or something like that. I've not seen it. If it's out there, it's fine. But one thing I need you to do, I need you to read the label before you buy it, because the one that I found on Amazon, I'm not even going to recommend it or refer you to it. It says if you put it out the recommended rate, it'll increase your pH by 0.25%. That's not going to do you any good. That's not enough. Yes, it is increasing your pH, but it's not going to do you enough. If you need increase in pH, you're looking at probably 1.5 to 2%, or 1.5 to 2. It's not a percentage. Sorry, it's a logarithmic scale, more than what you need to know. Anyway, you need 1.5 to 2 is probably what you're going to be looking for on typical pH increase. So anyway, but I just wanted you to know about the liquid products so you don't get snookered into buying something. Just read the label. Yes, they do work, but make sure it's going to give you the bang that you need for the buck that you spend. So anyway, I just wanted to give you exposure to that. Now, raising pH, or pardon me, lowering pH, getting the lowering. It gets a little complicated. But I will say this. It is hard to find publications on lowering soil pH because typically we're talking about folks out west. Most soils that are in agricultural use are typically soils that are not, a lot of these alkaline soils are high salt content where you don't have a whole lot of water. They also, the parent material is often limestone. Okay, soils actually derived from a rock, and then they throw a little organic matter in, a little bit of weathering, and that's you from a rock to a soil. Typically, in addition, if you have an alkaline material like a limestone, and that's the parent material, it's going to be very hard to lower the pH of that soil. There again, I mentioned about the soluble salts. If you live in a dry climate, an arid climate like in Arizona, like in Texas, it's going to be harder. And the other thing that can happen, you can have pretty high organic matter in that soil, and it could actually be a higher pH, and the buffering capacity of that soil, meaning your ability or its ability to absorb acids that, and I'm going to tell you how to get to there in a minute. A lot of these folks struggle with lowering pH. Now, I'm explaining to you why you're struggling with it. The buffering capacity of that soil is so much that you're really going to have to keep it up and keep adding and adding and adding, and it's going to be a part of a maintenance schedule more than it is just putting it out and then 5 years later having to worry about it. Typical soils, just to give you a heads up, if you take you're probably going to be adjusting your pH about every 3 to 5 years, ballpark, on an acidic soil. Okay, that's primarily a function of one, the parent material of the soil, and two, your fertilizer application, which typically can end up putting more acidity in the soil, and depends on how much kind of the quality of your water that you're putting on as far as irrigation. This can also run in the situation when you're out west. Sometimes your water pHs are high too, and you need to be aware of that. That's why you're struggling with it. Parent material, the water that you're putting out, things of that nature. So this is where these are things that can screw with your pH. Your fertilizers you use, typically they're acidic. Slightly, not a whole lot. Don't sweat this, but over time it can add to it. Now, as far as lowering pH, you can put sulfur out. You can put, I believe it's aluminum sulfate as well. That reacts quicker. Don't let your ears perk up for that. The problem with aluminum sulfate is, and you will see this in some publications, that it will decrease your pH quickly. However, it's really not a practical use for turf grass. Most of the ammonium sulfate that is put out to lower pH is done by farmers. I'm just telling you, if you read something and you come across it, it's going to be tough because there is a toxicity to it. It can damage the grass. So you're really stuck with sulfur. How does sulfur work, and why is it so hard to get the pH down when you're putting sulfur out? It's not like lime. It is not like lime. When you put sulfur out, microbacteria start munching on it oxidizes. Okay, the microbacteria start to eat it, and as they eat it and digest it, they produce sulfuric acid. And when that acid gets into the soil, that is actually what lowers the soil. So it is not a chemical reaction like this is. Basically, you're taking the hydrogen ions and getting them out of the soil. It is a chemical reaction. Lowering pH with sulfur is a biological reaction because the micronutrients have to munch on the soil, on that sulfur product, will break it down and produce the acid in order to get the soil down. Now, what do you do if you've really struggled, if you put out sulfur on your soil? One, you've got to look at these soil tests. That's why I want you to go with these universities so you can give them a call. It is sometimes based on if you have a heavy clay soil, the buffering capacity of that soil is very, very resilient, if you will. It may take a lot. Typically, what most of the recommendations that I have seen in lowering soil pH is take your soil sample, determine how much sulfur you need, and then 3 months later, take it again and see if it's lowering it. If it's not lowering it, and you could talk to the local folks there with the soil testing lab, because we're talking local stuff and things that go on, and those folks from that university are going to know the characteristics of your soil that's very specific to your area. And yes, soil is very specific. They're very regionally specific. I'm not going to get too much into that. My background is in soil science anyway. Just trying to give you what's going on in case you get discouraged. But anyway, those folks should be able to steer you in a way if you're wasting your time or not. Or how much sulfur you're going to have. You may have to continue to add sulfur because what happens is, as a parent material, that soil keeps on wanting to bump it back up, and you add sulfur. You're just basically counteracting that soil's ability to either buffer or produce alkalinity to keep that pH of that soil up. If you can get to 7.5, if you look back at that chart, if you can get to 7.5 or below, you're doing pretty well. Once you're going to get above 7.5, you get a potassium deficiency. You can get some potassium deficiency, and that can run into some problems because there, again, it's for rooting, it's for winter and summer survival in both cool and warm season grasses. So you do need to get that pH down based on your soil test. Use the sulfur. It's fairly cheap. Ammonium sulfate, let's say you did use ammonium sulfate, and you could use it because you're reseeding a yard. The one thing about it is it'd be ideal if you could till it in fairly deep, and you can use it. The thing with ammonium sulfate is going to take a lot more of it in compared to sulfur, somewhere depending on the soil textural type and the parent material of soil. I'm getting technical here, but I just don't want you to waste your money and know what your expectations are. You can get anywhere from 2.5, okay, let's say it needs 1 pound of sulfur to lower your pH. You're probably going to need anywhere to get the equivalent. Kind of going back to the calcium carbonate equivalent I talked about earlier. You may need 2.5 to as much as 6 pounds to be equal to that 1 pound of sulfur. So it's going to be a little more expensive, and it's going to be fast reaction if you're willing to pay the money. So, but we are in a no-till, getting the agriculture element of my background. But anyway, if you're in a no-till situation, it's very difficult to use ammonium sulfate, or aluminum sulfate, sorry, and to lower your pH. So stick with sulfur, stick with that soil test soil test recommendation, and if you need to, call back the soil lab. They will be happy to help you on a regional basis of how to handle how to lower that pH of your soil. So anyway, I will leave a few recommendations down below with the sulfur and a couple of lime products, but I'll be candid, you could probably find them at your local ag store, Walmart. It doesn't really matter, but I'll leave a couple down below if you want it. But anyway, as far as me, I keep my videos very topical. It is now August. This is a really good time to put your particularly lowering your pH. There again, raising your pH, lowering your pH is biological. You can put it out in August, and it'll probably munch and chew for a few months. Ideally, you want to probably put it out as soon as you can. But because it's a biological, if you're watching this in November, just wait till spring, because it's a biological reaction. Your microbacteria are not going to be feeding in November, December, January, unless you live in freaking Key West or somewhere like that. It's not going to happen. So anyway, but A little bit about me. I'm an agronomist. I'm a North Carolina State University graduate. I have a bachelor's degree in agronomy from North Carolina State University. Former golf course superintendent. Been in turfgrass management and golf course and sports fields for over 30 years, almost 35 years now. So anyway, appreciate you watching. I hope this helps. You got any questions, put them down in the comments. I usually respond fairly quickly within a day or so. And appreciate watching.